In this video, we're going to look at qualitative data. A frequency distribution lists each category and the number of occurrences for each category. The number of occurrences we're going to refer to as the frequency. Our raw data is the data that's collected in its original form. So it's our data sets. Again, that frequency is the number of data values that fall into a specific class. Relative frequency is also called the proportion, and it's the frequency of the observations in a specific class divided by the total number of observations. It's typically written as a decimal, but it could also be written as a fraction. And then percentages are the relative frequencies multiplied by 100. A relative frequency distribution is just a frequency distribution that includes relative frequency as a column. And here's an example of what this frequency distribution would look like. In our first column, we have our categories, and we would give the actual category names. In the second category, we would give our frequencies for each category. And in the bottom row, we might list the sum of those frequencies, which would give us our sample size. The next column would be our relative frequency if that's asked for. The sum of your relative frequencies is going to be 1 or very close to 1 if we have rounded any values. And then our percents, we take the relative frequency from each class and multiply it by 100. And when we would sum those up, we would get 100 or at least close to 100 based on rounding. For the categorical variables, the categories are the specific subgroups or categories that the data can be broken into. So let's practice filling in a frequency distribution for favorite pet. So we have in our first column the category or the type of pet, and then we're given some frequencies that have a total of 905. So this is actually in our sample size. To find the relative frequency for that first class of cat, we would take the frequency of the class, so 232, and divide it by the total or sample size of 905. And if we were to divide this using a calculator, we would get 0.256. So in this video, you're going to start seeing some calculations. I've already done a lot of these calculations, so please feel free to pause at any time to go through and actually do these calculations in your calculator. We're going to be using Excel here in the next couple of videos as well, which is a great option for calculators too. The relative frequency for dog, we're going to take 403 and divide it by 905, which as a decimal rounded to 3 decimal places is 0.445, excuse me. For fish, 181 divided by 905, rounded to 3 decimal places, this is 0.2. And it's an exact decimal, so we don't need to add any additional zeros. The next is 45 divided by 905, which when we round this, we get 0.050. So I'm going to pause here real quick and just talk a little bit about rounding. So when we take 45 and we divide it by 905, 45 divided by 905. We get 0.0497236, and that probably keeps going, but this is all that my calculator is displaying currently. So if we want to round to 3 decimal places, that's that third digit, we want to look at the 4th digit to see how we're going to round that 3rd digit. Since that 4th digit is a 7, we want to round this value up, which would actually go to 10 or 0, which also forces this one to round up. So we get 0.050. Now, let's talk about how that compares to 0.05. Well, it really is about communication. This implies that there were additional digits after that 5, and we rounded to 3 decimal places and it rounded to 0.050. Over here, this either implies that we were told to round to 2 decimal places, which in this case, we're sticking with 3, or it was an exact terminating decimal. So these do communicate very different things. And if you're asked to round a particular way, even if that last digit is a 0, if that's part of the directions for rounding, you want to make sure that you include it. All right, back to our frequency distribution. Our last class was for lizards. We're going to find that relative frequency by taking 44 divided by 905, which rounded to 3 decimal places is 0.049. Now, to find the percentages, we're going to take all of those relative frequencies and multiply them by 100, which is the same as moving your decimal 2 to the right. So this is going to give me 25.6%, 44.5%, 20%, 5.0%, and I'm going to include that 0 because it again implies that it was not an exact 5%, and then 4.9%. When you're giving percentages, make sure you always include that percent symbol. That is important. And again, we could sum our columns for relative frequency and percent just to verify that we didn't make any errors. If we're pretty close to 1 or 100 respectively, then we probably were pretty close and pretty accurate. Now let's try constructing a complete frequency distribution from raw data. So again, here's our raw data. It's just our original data set before we start summarizing. So looking at our categories, so we're looking at blood types. It looks like we have blood types A, B, O, and AB. Now with categorical data, a lot of times it does not actually matter what order we list our categories. So I just happened to list them in an order that made sense to me, but if you had it in a different order, that's fine too. Now there are special types of qualitative data or categorical data that we call ordinal, and that's qualitative data that has a particular order. For example, first, second, third, or freshman, sophomore, junior, senior. There's a set order that we would want to list those categories. But those are pretty obvious, and I think in a lot of cases we just tend to put them in that order anyway. But for something like blood types, there's no order to those different categories. Now, for the frequencies here, we're going to have to do some brute force. We're going to have to just go through and count this data. Now, we're going to learn some other techniques on how to organize data and make this a little bit quicker. But for now, we're going to go to those really rudimentary techniques of just counting tallies. So I'm going to start going through my data, and I'm going to go by column because it's easier for me to organize. And I'm going to start tallying in those frequency blocks where my data lies. So I've got one for A, one for B, one for O. Then I've got one for B, one for O, and then another for B. So now I've done those first 2 columns. And I'm going to keep on doing this process of tallying up my data. So if you want to go ahead and pause the video here, I'm going to pause our recording, and then we'll come back and check in on our tallies. So now that we've finished tallying up our data, we want to give our frequencies. One of the things I like to remind students is that the tally does not count as the frequency. It's a tool that we're using to identify the frequencies. So our frequency for blood type A is 5, for B is 7, O is 9, and AB is 4. Now, if we were to add all these data or all these frequencies up, we would get that N is equal to 25, which we could confirm is accurate based on looking at our raw data and making sure that we have 25 data points. As long as that sample size matches the number of data in our raw data set, that tells us that we're sort of correct, but it doesn't necessarily mean that our frequencies are correct. We're just not really missing anything. But we could have put data in the wrong class. So for our relative frequencies, again, we're going to take our class frequency divided by the total. So in this first class, it's 5/25 or 0.2. For the next one, it's 7 divided by 25 or 0.28. 9/25, 0.36. And 4/25, which is 0.16. And to get our percents, we're going to take those relative frequencies, multiply them by 100, which is the same effect as moving that decimal point 2 to the right. So we have 20%, 28%, 36%, and 16%. In our next video, we will look at taking the data or taking these frequency distributions and starting to look at some different graphs.